So hi everyone, today we will be participating in Education Codeforces round 169 Div 2. So I will try to solve 4 problems. I think the one of the most drawback about these rounds are the D problem is weight as much as the A problem. वो बहुत ज़्यादा issue आता है उसका कि मतलब difference क्या होगा. So let's try to do the round. We'll try to solve A, B, C, D. Hopefully we can. Let's start. Okay. Okay. Consider consider a set of points on the line. The distance between 2 points I and j is I minus j. The point I from the set is the closest to the point j from the set. If there is no other point k in the set such that the distance from j to k is strictly less than the distance from j to I. In other words, all other points from the set have distance to j greater or equals to I minus j. For example, consider a set of points 1, 3, 5, 8. For the point 1, the closest point is 3. Other points have a distance greater than 2. For the point 3, there are two closest points 1 and 5. For the point 5, the closest point is 3, but not a since okay. For the point 8, the closest point is 5. You are given a set of points. You have to add an integer point into the set in such a way that it is different from every existing point in the set and it becomes the closest point to every point in the set. Is it possible? Closest point in the it becomes the closest point to every point in the set. So there are like 1, 3 points. 1, 2, 3. Obviously this will be closest, this will not be closest. It will be like in 10 uh, we are n rooms arranged in a row. There are n rooms arranged in a row, and the n minus nodes between them. Something atoms is easier, I guess. So this, I think this may be the easier. Let's say Alice and Bombay and atoms, they like to split between them, so they decide to play a game. All atoms have a cost, and the ith atom costs AI. Players move in turn starting from Alice. Okay. In each turn, the player chooses one of the remaining items and takes it. The game goes on until no items left. Let's say the A is the total cost of the item taken by Alice and B is the total cost of the mob. Resulting score of the game there will be A equals to A minus B. Okay, which is fine. Alice wants to maximize the score, whereas Bob wants to minimize the score. Both Alice and Bob will play optimally, but the game will take place tomorrow. So today, Bob can modify the cost a little. He can increase the cost of AI of a several. Um, Possibly none or all items by integer value. However, the total increase must be less than or equals to k. Otherwise, Alice may suspect something. Notice that Bob can't decrease cost, only increase. What is the minimum possible score Bob can achieve? What is the minimum possible score Bob can achieve? Okay, let's say A is the total cost of taken by Alice and B is the total cost of the Bob item. Resulting score of the game there will be equals to A minus B. Okay, that makes sense and that's rated. There are n rooms arranged in a row and n minus 4 rows between them. N rooms arranged in n minus 1 rows. The I door connects room I and I plus 1. I and I plus 1. Okay, fine. Okay. Each door can be either locked or unlocked. Okay. Initially, all doors are unlocked. Okay. We say that a room X is reachable from room Y if all the doors between them are unlocked. We know that Alice in the some room from the segment LCR. Bob is in some room from the segment LCR. Alice and Bob are in different rooms. However, we don't know the exact rooms they are in. You don't want Alice and Bob to able to reach each other, so you're going to lock some doors to prevent that. What is the smallest number of doors you have to lock so that Alice and Bob cannot meet, regardless of their starting position inside the segment? Okay, so LNR and LNR. So if they are not intersecting, then only one room needed. So let's say if it's 1, 2, 3, 4, so we need one room. If it's 2, 5, and 2, 5, then you need three at least. Okay, and if okay, so if it is 3, 7, and 6, 7, so you need like 2 rooms. Okay, so you want to lock, let's say lock this room. See, if he can be in this room, if I lock this room, if I lock this room, then is there any possibility that they can intersect? No. They, no. Okay. So why don't it's not a possibility in 2 and 5? Okay. 4 and 5. Two and 5. How do you assure me or saying it? Okay. Sorry. You say 8 and 4. He can be in 4th room, he can be in 4th, he can be in 2nd. Okay. So 2, 3, 4, 5, 6, 7, 8. This not extended. So it's coming in 4th room and 5th room. He can be doing it. Okay, that makes sense. Hmm. Okay, and if it's 2, 5, then it's 3. Okay, so if it's inside basically, uh, then we have to like, okay, and if there's no splitting, which is uh, here like this, it's different, I guess. Okay. So if it was larger, let's say 3, 4, 5, 6, 7, I put in like it was forced to so you need to implement so two will this way, so you need just two. Okay. Okay. You got the logic? Let's implement. Okay. Page over so int LR and int they can't be in same one, so that's why once it goes to final. One big password. It's fine. Is less than equals to x minus it. Okay. Otherwise, what happens is if x, which is fine, r less than equals to x, then it's fine. Now the case where it's completely overlaps, okay, completely overlaps, that is the case. Yes. And we don't know, we don't talk about this thing, okay, these segments, but this is the case. And similarly, we can like replace this with like this thing. So if then we should apply this. If n is greater than x, let's assume. So if n is greater than x, so okay, basically about now if n is greater than x, which is okay, but replace the words. Okay, लेकिन आपको let's see r के बदले b x के बदले a y के बदले b ठीक है else that is clear else that's not the case so l is like if l less than x it's fine if l is equal to x then they are so if r is greater than like if r is lesser than so there is some overlap so let's assume l is like that r is lesser then we have to change it we don't have to change it only l thing we have to consider replacing it so हमेशा l is will be from here to here something x will be from here to here this string or can be here to here so it doesn't matter so we just have to check with this case okay now if l is greater than r now then the next sorry otherwise okay now what happens r is not in x let's assume x is intersecting this so let's say x is x and x so if y is less than equals to say x plus where y is greater than that okay let's say y is less than that so it's going to be close so that is the clear what happens is okay so count okay equals to let's say which is y minus x, and if x is greater than 10, plus if y is less than r, plus. Okay. That's the case, and if r is basically greater, yeah, also makes sense. If r is greater, so what you have to do is x r is less than x. If x is equal to r, then say okay, y is plus, we can be like we can be here. Okay, so that is the case. Now, if this is the case, so count is this. अगर y मान लेते हैं r से बड़ा है, so तो लगेगी जब really plus one if x is like not attached to any inputs. Because let's see what we do this. If that's one, three, two, three. Okay. Accept it now. Okay. Okay. Thanks. So it's easy to solve it first. Alice models and items. Okay. The game goes on until no items left. Let's say A is the cost of items taken by Alice and B is the cost of items taken by Bob. The resulting cost of the string is left. Alice wants to maximize the score while Bob wants to minimize. So Alice will try to make as much as possible, and we can increase the cost of AI cost You can increase the cost AI of several items by an integer value. Okay. The total increase must be less than or equals to k. Okay. Otherwise, Alice may suspect something. Noted Bob can't increase the cost to increase. So, what is the minimum possible score Bob can achieve? Minimum possible score Bob can achieve. So, Bob wants to maximize things. He will try to maximize as much as he can. So Alice will move, so the all items are cost. Okay. In each turn, players move in turn starting from Alice. So Alice will try to like what Alice has to do. Alice has to maximize this. So Alice has to take score A faster, better. So what Bob wants you to do is increase the cost as much as you can. So if Alice is taking this much cost, if you can increase the K cost, just take the second one with A cost. Uh, 10 and like you can increase it by k which is 5 6 uh 6 4 okay 15 and you can increase by 0 to 15 like 5 minus 12 which is 13 4 okay to increase it till max okay it's easy uh int nk and yeah yeah okay now store because this is not here and k greater than 0 ठीक that is the thing that to take array of n minus 1 minus array of I. So if A is greater, if A is like, yes, yes, minus array of I. So if A is greater, uh, then A is equal to A. Obviously, if I increase this, it doesn't benefit to me to anything else. It just benefits us. So I increase it by a k, and what you do is you just update this. Okay, I guess that is the thing. Now what happens is okay, I increase it to the time increase. A third question I will not increase because if I increase it, Alice will. So I will increase this one. So n minus one is 0 and it equals to I is 2. Okay. So array by person. Okay. Okay. K minus now. Uh, okay, it doesn't matter actually. So it doesn't matter. Do this and sum. So minimum possible score. Okay. Next one. Let's go. Standings. D problem. I think so. Standings. Uh, which is 1200, which is good, I guess. Uh, okay, fine. Okay. I prefer the D problem, I guess. D problem is solving pretty fast. Okay. There are n cities located in the straight line. The cities are numbered from 1 to n. Portals are used to move between cities. There are four colors of portals: blue, green, red, and yellow. Each city has portals of two different colors. You can move from city A to city if they have a portal of the same color. For example, you can move between blue and red city and a blue green city. The movement cost unmatched. Each city has a portals of two different colors. You can move from city I to city J if they have portals of the same color. For example, you can move between a blue red city and a blue green city. This movement cost I minus J points. Your task is to answer Q integrated queries, calculate the minimum cost to move from city X to city Y. Okay. The second line instance of runtime BG this as I describes the portals located in the I city. The symbol B indicates that there is a blue portal in the city. The G green city address. The jth of the next few lines contains two integers x1, description of the jth query. You have to answer minimum cost to move from city x to city y or minus one if it's impossible to do so. Okay. So let's see. Once you to move technically one cost. Please one. If the explanation, no explanation. So portals are used to move in a city. There are four color portals. Each city has a portals of two different colors. You can move from city if they have portals. अच्छा move कर सकते हो. So okay, if they have the same color portal, they can move. Okay. So we just need to figure out what the cost or minimum cost it requires. Okay. So let's say if I have to move from third to first. Okay. G by say I firstly have to move to G. Next G I can move, and from G. Okay. Next graph. First, we will draw the graph and see if we can solve this. Okay. Our rating is like 1200, so like it will be fine for me. Like it will not be like too bad. Uh, okay. First to second, G1. If we can't move from here, GR. We can move to third and a minus one if it's impossible. Okay. 1, 2, 3 and fourth and third. Okay. And there can be more connections between them. Okay. And we have to figure out, okay, from here can we move to here? It's not a trade heading and city moment cost होगा. अच्छा ये cost करेगा and J cost करेंगे. Okay, fine, makes sense. So what is the minimum rate to go? Maybe there is a possibility that it could have like, if let's say this is one, there's a connection between them. Maybe there is a connection between them also. Not necessarily because we get different colors and this different colors. Okay. So you just have to figure out minimum cost to move from city X to city Y. We can use like a DSU to figure out if they present it or so they can travel. Okay. Now what logic I can use to like travel? Use the blue concept. And the people have the same blues and same grids, they're already connected. So they can move. Now moments of is any connection. So it's connections so like you get an answer directly by things and the same, which is much better because like it's 1, 2, 3, 5. So I think which is 2 and 3, 2, which is 4. Same thing. It doesn't matter. So if a direct connection is fine, if the direct connection is not there, so we'll figure out okay from here. If we are not directly connected, we are connected by something. So like you come here, and you come here, we are connected by some points. Maybe this, maybe maybe this. How can you reach between faster way and better way? If we know if the people that are P are in same group, and they can be have like certain connections to, we can find the groups here. How do we figure out that this height, this way, this distance? How distance is is there any way to like use that concept? Can we use binary lifting or something like that? I think we can use binary lifting. Uh, anybody can be. I think there's no tree concept. No directed graphs don't have. Anybody can be anybody like this. So let's say green. So one thing I observed is for this to match these both, it's not the thing. It can be like right. So you know what happens is when they be a housing and when they be a second, largely and busy, we are saying so okay, next observation. There will be two colors. The only possible way that they are not directly connected is if they don't have the same colors and they have four colors. Okay. So when it was 3-1, let's say I want to find an element which has like the same color with them. So either it's G or either it's Y. So okay, so G से Y गया या G से मैं R गया and Y से I can go somewhere which is like uh, I can go to G, then I can go to G, but I go to like R there. Now and from there, now I reach it at G, I can go to. So if I'm G and R, I will be preferring to go to Y, and I will be preferring to Y. So GY, I want to like I can go to GR. I want to go to Y, there is nothing. Okay. And from GR, I can go to VR. Okay. And it's just always better to so if I'm like okay, it can't be like more than 4 because sorry it can be the distance can be not more than 2 because if I'm Jewish I'm going to somewhere which is not same as this so there will be a something which connects to this so I can say this so my traveling is like 2 times only okay so 2 times traveling okay fine so just have to figure out which they are the same color from they don't agree. If they don't they have then I manage to is the best thing because see let's say if I do this so the matter okay and what you need okay and if they are not they are like a different color G, Y, G, different idea. It's something like this. Either you can use DSU to check that either created it's no. And second, which is minus they come to 9. So you can use DSU to check it. The best what you can do is just find the element with the minimum value in mind when we happen. So find the element which you can use in the binary search, I guess. Okay. I get 2, 3 things. I think we can solve this problem. We can just try this problem. 326 people as well, so it's not a very tough problem. Why it's not working? Net PSU by 6. Okay, this. Okay. Hmm. Extend. Okay. And this is okay. Okay. Now so BRG कितना है BGRY है ना BGRY BGRY now we do this. Uh, I mean, demonstrate. Now, now what you have to do? What you have to do is like you have to figure out if it's like DSU creating DSU, right? If they can taste the same parent or not. And we can use this like this. Okay. Whenever you are all pattern, when you are here, it's use PB. So everybody contains B. Okay. You take the modify and then it's written to this main thing is here. Very important. This, okay. मीन बस सबसे जल्दी कर सकते हैं ना जब okay. Uh, take the speed this case like this and read the speed like okay, now I can see it. So what you do is you just add 0. So if 0 b b then b g r g r y. Okay, if this is the case, RG, BRGY. Okay, so what to do is, sorry, is equals to 0. So 0B. So LB dot at B at TV. Now similarly, so जो भी है वेक्टर निकालो yes. Okay. So we can assign this here. A B G B G R Y. Okay. So I can do this. Okay, so that makes sense. Now we do this all the time. Now, okay, BSU. Now, let's see. And I select this only, and it's fine. X minus 1. Now, minimal value can go to now. Take all the elements of this thing. I assume so we can add as the read or steps because I am going to we need a boolean size which is get 0 get and similarly this paste 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 and be LB LG NRL LB LG 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 and So incidence elections we participate. That's okay. This is done by investors. Now what is your task? This task is to find the watches and lost records. So you can now if you are interested, if it's not the case, maybe they are connected in some ways. Okay. Now how will you do it? If there is a similarity in this or not. Uh, जीरो को तो चेक कर लिया दोनों के साथ 0 0 0 1 1 0 1 1. Nothing is happening. If this is the case, then there is like okay, there is simply yes. Okay. Otherwise, that's not the case. If this is the prevalence plus minus 4 0 and 1 4. It's not gets connected. So the thing is, now if you are to give this not the case, so then we have to find other element like other benefit than this characters to factor up. So and then what was character factor up. So we have to find the character which is like अब उस कैरेक्टर से हमें क्या चेक करना है क्या वो कैरेक्टर which is not which is the character which is obviously present in this have this character as that. So obviously there may be some element which has these four qualities because there is no element which has both these qualities if you want to talk. What you want is the element which has this quality to be at B and have G, B and G, G of my both, and you just figure out what is the element it has, which is best, which is between this, and if it can't be between this, then you just figure out the next step. I think I can solve this. Now we just have to check, okay, and we can store another values now. So BG, BI, बीजी हो सकता है डीवाई हो सकता है डीआर डीआर हो सकता है और क्या हो सकता है जीआर जी 1 2 3 4 5 4 है ना 4 से 2 एक को होना चाहिए बीजेपी ओके जी आर जी वाई हो गया एंड आर वाई यूनिट्स आर वाई ओके आई थिंक दैट इज द थिंग इनको एक असाइन भी कर सकते हो सो what we need to figure out is कि ऐसे एलिमेंट जो दोनों कैरेक्टर को जोड़ के बन रहा हूँ इज देयर एनी फोर CRR1 which is A B C D A B C D E F G H I J K L M N तो B के बाद G आता था तो B G R वन B G R B G R okay so makes sense so out of J and K ठीक है तो हमने स्ट्रिंग निकाल लिया अब हमें ये देखना है कि वो स्ट्रिंग एक प्रेजेंट होना चाहिए और कुछ होना चाहिए और उसका आंसर निकालना तो okay and that is the thing now what I have found out कि okay एक जस्ट एक वो क्या बोलते हैं असाइन कर देना चाहिए वो एलिमेंट्स जो 6 के 6 बनेंगे ना उसमें लिस्ट ऐड कर दो एंड वी जस्ट फिगर आउट दोनों उसमें प्रेजेंट हो और उसमें प्रेजेंट हो and the string should not be equals to this so if I1 that equals अगर I1 इक्वल है उसके जिस करंट इसके x और x x equal then we don't know that there is not a single element which resembles with it then also it's a problem which we can use it like this yeah. A character so what we want हम ये चाहते हैं कि जो दूसरा एलिमेंट है जो बी में प्रेजेंट है और जी में प्रेजेंट है और एक दूसरे कैरेक्टर में प्रेजेंट है उनका हम फिगर आउट कर सकते हैं चीजें कर पाए बेसिकली ये हमारा मेन है सो this is what we want to do so we have to figure out the string अगर string same then it doesn't contribute to anything we don't want to go we just have to figure out a string which is like a different string which resembles with okay it's not equal to this means that always be bg br by, gr, gy, and ry. There is always a string that is not there from. The thing is just fine. अब ये जो स्ट्रिंग बना रखा है इनके लिए मैप क्रिएट कर देंगे तो स्ट्रिंग को सब कुछ असाइन कर देंगे ठीक है list which is 6 and then still have to mention created. Okay, now what happens is they just find being the number is equals to being a list. Okay, now similarly you have to just add this. Take beach beaches. ये आपकी बीजी बीजी BG, BR, BY, RG, RY, and BY. वो तो वैसा 4C2 बचा कौन सा BGRY ये हो गया 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 RG ओके BG BR BY GR GY अच्छा सॉरी BR GR and G RY okay that is fine and BG RY which is fine and there is an element source which is fine which is arranged in such a way type okay हमने string को मिला के parent मैप अपने मैप से वो स्ट्रिंग्स निकालते हैं कि कुछ भी मैच नहीं कर तो अदरवाइज आंसर ये जे से 0 से 5 से करो अगर स्ट्रिंग i1 is matching to string map dot get x which is basically a then paper continue कर दो otherwise what do you have to change it is something matching is there you just have to check that see this your change this okay nothing is matching and replace it with iron this iron sorry 8 is 7 iron so is अगर इनमें से एक में भी नहीं आ एक में है तो फाइन एल्स व्हाट यू डू एल्स यू कंटिन्यू मतलब कुछ सेम ही नहीं कर रहे व्हाट यू डू नाउ एल्स वैसे यहाँ पर जी वैसे था अब जी आर जाना पड़ेगा आर का हमें मिल जाएगा तो we just need one element which has same and also is there. Just find the number which is between this. Is there any element? Or take any element which is between this or this thing. Right? चेक करना है ये तीन एलिमेंट प्रेजेंट in I1 the pass is another one is uh, something is same, which is fine. The array of man get here man get I get the class list class variable, and what you have to do is okay, just we need this and we just need to check okay get okay okay after that we just do the answer. So, X uh, so now it will teach us sorry into max one X and else you get that answer, which is like okay, now अगर मिल से छोटा है obviously we have to make sure that this is not the case. And बीच में अगर बीच में मिलता है पेंसिल से वो मतलब is plus x minus x so just we want it to be like minimal. So if it's it is greater than it's not different from the minimal. And hence, something is behind there. I will go till here plus this. Similarly, it's the same thing. It doesn't matter. It's if it's a greater than min. It's okay. Equal to and say else a is means it's छोटा which is fine. Then answer and a and if it's the case just then balancing plus balancing and we have to move towards start with this. Okay, now similarly which is we have a good thing. If it is like if A is less than equals to B, action, then starting the performing else, else if it's less than it's fine, no problem. But else if A is lesser than equals to B, it doesn't have the same thing. So what happens is it can same thing. Okay. That will contain being able to make its assumptions. Let's solve. Assumption 167. So it's not doing okay. So what is the issue? I want A, B. GB. Oh, sorry. One two zero three two minus two. That is actually okay. So answer one. Answer two. Answer three. So answer this. So the second one's for which I will discuss. वन वन के लिए हमारे पास क्या था बीज but A which is G1 बीजी था सो बीजी का तो कुछ था ही नहीं इसके बाद टू आंसर बीजी को वहाँ से आंसर हो गया टू बीजी बीजी का बीजी में वो एलिमेंट प्रेजेंट है वहाँ की वजह से बीजी आ गया बीजी में एलिमेंट है आएगा से बीजी में एलिमेंट okay BG it's calling out to be 0 1 2 3 yeah 14032 minus 14032 minus 1. चल जाए जल्दी यार, कितने टेस्ट केस है. एक्सेप्टेड. चलो प्रॉब्लम, ये टाइम लग गया. बहुत इजी प्रॉब्लम था, बट टाइम लग गया थोड़ा ज्यादा. Fifth problem is like looking like doing it, so we will try the fifth problem. So now let's check this. Okay, so we have to solve the four problems. This problem, like, okay, I could have done better implementation, but I like wasted a lot of time in implementation. uh, I shouldn't have. uh, this reference. Okay. Two players, Alisson, were playing a game. They have n piles of stone. रुक जाके वॉशरूम जाके आता हूँ एक बार, आ रहा हूँ 2 मिनट में. I'm back. Let's try the E problem. I think E problem is not very high. I think it's not a NIM problem नहीं है. हो सकता है NIM problem ही हो. Let's read it. Two players arrange ball are playing a game. They have n piles of stones and the ith pile initially containing AI stones. ठीक है. Okay. Piles of stones. Initially containing AI stones. On each turn, a player can choose any pile of stones and two players, Alice and Baba, playing a game. They have n piles of stones with the ith pile containing AI stones. On their turn, a player can choose any pile of the stones and take any positive number of first n piles है on player can choose any pile of stone and they would took any positive number of stones from it with one condition. Let the current number of stones in the pile be x. It is not allowed to take from the pile a number of stones y such that the greatest common divisor of x and y are not equals to 1. So it is not allowed to take from pile number of stones y such that the greatest are not equals to 1. Acha. So it is not equals to 1. So okay. So you only can take the numbers which are like basically GCD, which are basically divisible. So numbers, okay, common factors. Two players who cannot make a move loses. Both players play optimally. That is, if a player is a strategy that allows them to win no matter how the opponent responds, they will win. Alice goes first, determine who will win. Okay. Uh, okay, that's interesting. Probably. So I mentioned it. So the task of for a person is should make it in such a way that take the numbers, which is a GCD, take the number which is not a GCD, such that they form a number, which is a prime number. Because if it is a prime number, you can't take that. Okay. Okay. So, yes, I think we got this. If it is a prime number, then you can't take that prime number. So there are some numbers. What Alice Bowen this will try to do is take a number which can be become prime. It depends, I guess. Because if there is a odd numbers of numbers which are not prime, then okay, I can make this prime. So then I can take that. Uh, so what Bob will do is Bob will not make this prime because prime. Then I think Alice has a lot of choices. Okay. There may be some pattern to it. Okay. 3, 3, 6, 4. Alice wins. Otherwise, Bob wins. There's 1, 2, 3, 4, 5, and 3 to 9. Okay. We can see observation. Here the number of prime numbers are greater than composite numbers. Here the number of primes. Uh, by performance. Alice will move. It's nothing. It's a still pass. That takes something. Okay, so whatever you take, Alice can obviously take one because it's GCD one, but GCD one case. So there is always a choice to make to choose. Still bobbins, like how the bob is going. If it is a 9 case, then I will take one, so it's 1 left, 2 left, 2 left. Then bob will do is bob chooses. Okay. So if it's odd, I think always bob will. And if it's even, then it's bob. It's not the case. So it's going to. So here, Alice versus Alice is Alice. make it one or make it like lesser than one, like we have a choice to make other than to that to make it one. Whatever right, let's say if the element is like n3, let's say you will take one takes one still ones. So every time one will be left. Now Alice is winning here. Alice take this. Now it's back change. Okay, okay. Here's the sensible thing. Hmm. So if number one is become one thing, so this chart and to the ball. So how do you want to do this thing? How do you make this one? Only choice like Alice has if there is a one person and it's not about edge, otherwise there is no way it works. Otherwise they will give you a one person and once you want this thing. Hmm. So it's about chance and it's not about this. I'm thinking of something. I don't know if it's right, but like it's coming in my mind something right. If this is okay, thinking okay. So we can say this is the case, and let's go. Okay, let's continue. Okay, so now other ones count even one. take one. Take zero. Okay, we are having Excel. So if this and this and if okay, so if X is not present only, so the answer is basically it was not present. Then it depends. When it's not present, so it depends only on like only on the A or number or something like that. That's it. So, if anything that you can answer, that's it. Yes. Okay. So Alice loses all the time if it's even also. So even if it's this thing, say it's 2, 3, 3, but okay. Somehow I come to conclusion if it's a zero, obviously the problem will there is no choice to problem on here. And else like a link. Okay. It's a zero problems. There is no choice. So Alice can win in any case. In one case Alice can win. No way you can't win. So Alice can't win only basically. So if one is not present, Alice can win. If that's not the case, so x is greater than 0, and if y is 0, then we also have like consider the case. Yes. So x is greater than 0 and y is greater than 0. So if x is 0 से बड़ा है, y is 0 से बड़ा है, then what can be the case? By here the adjustments and by here the problems. Uh, yes, let's say adjustments. So if okay, So if elements, yeah. If I can figure out why Alice can't always wins, let's think. Alice has like always the upper hand of Alice functions. So see, if Alice makes Bob is like in this position. Okay, so Bob is but here the Bob wins because see, there is the option to make everyone here is why this is only the case where okay, it makes sense. How much time is this left? Like 20 minutes, let's think. Many people have solved it. Many good people have solved it when there is a requirement. I can think of it. Okay, this was so here. This is so Alice moves this. Bob has to move this. Only option on this. Alice moves this. We have to move this and Alice will move this and Alice wins. So in 1 to 2 case, Alice wins. If I take this case, so whatever cases you take, it's always in 22 positions. Which causes us to win at 22 positions. But here the Bob is. How it is Bob is winning in this and in this. Okay, so there is only even number of numbers. But if there was like four, usually has to be one. So one is like a 10, let's say. So for the 3, we can do that. Let's use the make an element such a way that it turns from all elements or even abroad. This is it. Okay. Okay, okay, makes sense. Hmm. Yeah. Which has a number which is like divisible by this thing. Is there any number which is divisible by four terms? 600. So, what is the question? But what does it take? Just to this element, just execute what it does. It just reduces it to like it's like, so we need to manage. Here is a number which is basically not divisible by it. Let's say if there is more than one number like this, then it makes sense. So it just contains so like this. So the number of evens are less ones. You can make the number of moves odd times again. One move, two moves, three moves, so 2, 4, 5 moves. 2, 4, 6, 8, and 9. Can we increase the number of moves? That is the main question. How many times like 15 minutes, okay? So if you can't, then the answer is this. If there is an element which can increase the moves, please do let's say something. So if it's odd, you can have. If it's even, you can't. Or maybe if you have more than which is like five, you can have. Okay, so you have so you can make stones and yeah, it's fine. I can use one also. So what is a common thing? Common thing is I can make this one. You can have one. Okay, so you can take one. So one layer, let's say which is fixed. Okay. Number of leaves is 2, 4, 6, 8, 10, 6, 9 leaves. So obviously dog has to win. Now, the major game changer here is can Alice take someone from you? Yes, you can take someone from every game. So I can do that if it's you. Alice this makes this work by making it cheap. Six, eight, and inside so what is Alice trying to do? Alice is basically what she's trying to do to navigate second minutes. Alice is what they're trying so you can reduce every operation to like other than one like two operations, or you can take like more than two operations. Like with five, you can like reduce it to like three first, which is one operation, plus two, which is three operations. So you can do this way. There are a lot of ways that you can do. What is the thing that I'm missing? We are missing something very crucial. Uh, missing something crucial. The condition is you can reduce everything the way you want it to be in two steps. So let's say if it's 1, 2, 3, 4, 5, and I've seen everything nine steps. So this I don't want. So I reduce this to now they're like 2, 4, same nine steps for now, but it's for 9 steps. So what I will do is I will reduce this to one. Still, about losing so the thing is, if number of countings is odd, it will always be one. It's 2 plus 2 plus 2 to 6. So it's 6 then. It's there will be a reason why this is used. It's even. It's odd operation, cross operation, still boggles. Uh, why LS doesn't win? So can LS wins somewhere? Two, 4, 6 is no accuracy. It's like a number of operations here is 3. So what's it? I have to make some changes to it. It's definitely 3. We will reduce it. So when Bob fans come about, maybe it should use it. So whatever you use, it makes sense. What just makes is this that makes operations. It's uh, that means अगर मैं one twos are fixed with the operations of the linear, count the number of operations here. How many operations you can have from here? So from here, what LS is 3 operations, no, LS will want. So LS wants to maintain this. So it do 4, 6 things. LS wants to make this reduce your chances. LS will do something. What can make it into steps? Let's see. So mm, will win whenever there is like uh, being one here is always two. I am 48. I'm doing pretty well. Okay. So, yes. I will try the fifth problem. I am thinking of some solutions, but it's not very clear. So hopefully you like the video. अब प्लीज सब्सक्राइब करो और आप चाहते हो कि और बेटर वीडियोस और स्क्रीनकास्ट है तो प्लीज आप सब्सक्राइब करो और हो सकता है माइक क्वालिटी थोड़ी डाउन होगी माइक क्वालिटी में इंप्रूव करने की कोशिश करूंगा सो लाइक ओके बाय